Sushi is a meal that appeals to the discriminating palate, but it had very rudimentary beginnings. The first sushi was actually a form of food preservation. Salted fish was covered in cooked rice and left to ferment for months and even years. The rice was then thrown away and the fish consumed. A fresh approach came about a century ago, when the Japanese began combining raw fish with pressed mounds of cooked rice. It was a mouth-watering combination and brought something entirely new to the table. Rice is now an essential part of sushi. Sushi chefs use short or medium grain because it sticks together better than longer grain. The rice undergoes a thorough washing. First, the chef swishes it around in water to rinse off impurities. This also begins to remove the rice bran, which has an undesirable flavor and aroma. He drains the rice and adds clean water. Next, he scrubs it with his palm fairly vigorously to remove more of the rice bran. When the water becomes cloudy from the bran, he changes it again. By now, the water has softened the rice, which makes the grains prone to breakage. So he scrubs them more gently this time to keep the rice grains whole. Finally, he rinses the rice under a running faucet until the water drains clear. This rice is now thoroughly washed and ready to cook. So he adds an equal amount of water and a splash of sake and plugs in the rice cooker. The previous day, he seasoned rice vinegar with a strip of dried kombu seaweed and left it to soak up the flavors. The flavored vinegar is key to making good sushi rice. It's what makes the rice sticky. He pours the sushi vinegar into the cooked rice and evenly distributes it with a gentle folding motion to keep each grain intact. He fans the rice and grains dry to a nice sheen. With the rice prepared, it's time for all the raw details. Each fish must be assessed for spoilage or damage. The chef lifts the gills to confirm that the flesh underneath is red and translucent, essentially fresh-looking. He also examines the eyes of the fish. They should be bright and clear. He then prods the skin of this sea bream fish to establish its firm. Once he's satisfied, he prepares the fish, first scraping away the unpalatable and messy scale with a rasp. Next, he uses the thin edge of a one-sided blade to fillet the fish. Razor sharp, this knife cuts cleanly through the fragile flesh. He slices off and discards the head. He then carves the flesh from the backbone. Now, firmly grasping the tail of the fillet, he cuts the skin from the flesh, using a zigzag motion to pull it away. This technique leaves no flesh on the skin at all, so that not a morsel goes to waste. Using fishbone tweezers, he extracts all the little bones. He now slices the fish on an angle across the grain, using one long stroke that doesn't tear the fibers the way a sawing motion would. The result is a shiny, smooth piece of sea bream. Next, he peels away the transparent outer skin of a marinated mackerel to expose the silvery subskin. The gorgeous subskin is a feature that adds presentation value to the sushi, and it's also tasty. Next, he carves tuna that's been frozen within hours of being caught. This locks in freshness so that when thawed, it's suitable for sushi. And the freezing also kills any parasites in the fish. He chops spring onions into thin rings. They'll be used to offset the strong taste of mackerel sushi. He then mixes water and wasabi powder to create wasabi paste, the pungent condiment that adds kick to sushi. And with all the ingredients prepared, it's time to start rolling, so stay tuned. Once a simple food sold by Japanese street vendors, sushi has gone uptown. Today, skilled chefs produce bite-sized morsels with gastronomic artistry. A blend of color, texture, and taste, sushi appeals to the eye as well as the palate. The chef moistens his hands to keep the rice from adhering to them as he works. He dabs wasabi and places a ball of rice on one of the tuna slices. He pokes a hole in the center of the ball to introduce air. This keeps the rice from compacting as he shapes the fish around it to make a type of sushi called nigiri sushi. To form nigiri, the chef works swiftly to minimize the fish's exposure to his touch. Human body temperature is much higher than room temperature, and prolonged exposure to it would compromise the fresh taste of this sushi. A little pickled ginger to cleanse the palate, and this sushi is ready to serve. To make cucumber rolls or kappamaki, he carves the outer part of the cucumber into a long, wide ribbon, stopping at the soft core. He slices the ribbon in two and layers the pieces. He then chops the cucumber into uniformly thin sticks. This exposes more of the vegetable's fiber to maximize the taste. This is roasted seaweed called nori. He places it shiny side down on a bamboo rolling mat. He lightly presses rice into a ball so the grains stick together as he transfers it to the nori. He spreads the rice evenly, leaving a margin of nori at the top. And now he's ready for those expertly sliced cucumber sticks. He groups several in the center of the bed of rice. Then, gripping the mat on one side, he folds the nori around the fillings. As he squeezes the pack, some rice spills into the margin of nori at the top. But there's still enough space to create an overlap and seal the ends of the nori around the fillings. Using a wet cloth, he tucks in the overflow at both ends. He slices the roll in half. He aligns the halves and slices 3 times to create 6 pieces. Each piece approximately the same height for an attractive lineup. Next, he makes uramaki, a kind of sushi with rice on the outside, which is why they're also called inside-out rolls. He spreads rice evenly over the nori and flips it around to the shiny side. He dips a finger in wasabi and spreads it on the nori at midpoint. He arranges tuna on the wasabi-coated section. The raw red fish is then paired with slices of avocado for a tantalizing contrast. He folds the rice-coated nori over the fillings and tucks it around them. He continues rolling until he reaches the edge. He garnishes the rice with toasted sesame seeds for visual interest and tasty crunch. He covers the roll with plastic to protect it from the grooves of the sushi mat as he shapes it into a tighter pack. He then removes the mat and carves the inside-out roll into bite-sized pieces. Inside-out sushi was invented in the 20th century to appeal to Westerners who preferred not to see the nori. The final thing on the menu is the hand roll, also known as tamaki sushi. He presses soft rice into the crispy nori and layers the next ingredients diagonally over the rice: wasabi, a Japanese herb called shiso, and 2 pieces of tuna. He folds the nori around the fillings to contain them in a seaweed cone. Now all that's left is the presentation. And when it comes to sushi, less is more. Over-garnishing can detract from the main event, the fish. A simple, artful arrangement puts the focus on its raw appeal. Tetra Pak containers keep drinks and food products safe to consume for up to a year without refrigeration or the use of additional preservatives. Made mostly from paper, they're recyclable into things like egg cartons, paper towels, and toilet paper. A Tetra Pak container is packaging built with nature and freshness in mind. Tetra Pak containers hold all sorts of food products from smoothies to fine wines. The package gives products a long shelf life because of its special layers. The plastic layer, the paperboard, and the foil. A plastic coating makes the package leak-proof. Tetra Pak containers are made entirely from recyclable materials. The first step to making them is printing. A worker selects the appropriate printing plates for a given customer and applies them to the cylinder of the printing press. The press transfers one color at a time to the paperboard layer using solvent-free ink. A Tetra Pak container can have up to 6 colors. At full speed, it takes only minutes to print. A strobe light visually stops the motion, helping the pressman check the quality of the printing. A worker feeds the printed paperboard into a lamination machine that will join it with the plastic and foil layers. At the same time, the worker loads a roll of micro-thin aluminum foil into the laminator. A gas flame heat treats the paperboard to ensure adhesion to the plastic layer. The laminator extrudes liquefied plastic between the roll of aluminum and the heated paperboard. Rollers squeeze all the layers together. The printed paperboard, with all its protective layers applied, then comes off the back end of the laminator in a large master roll. The operator threads it into a cutting machine called a slitter. It cuts and winds the printed material onto individual rolls. The slitter's knives cut the material into 4 lanes, each of which becomes a smaller roll. The operator trims the excess material from each roll. Then a conveyor system sends the rolls for shipping to a packer to be filled with their product. At the packer's plant, an operator loads the roll of flat packages into a filling machine built and installed by Tetra Pak. Tension rollers guide the material into the filling machine where it is sterilized. The machine then forms and seals the material into one continuous tube. And a little further down, the machine fills the tube with product. It then cuts the tube into individually sealed packages and drops them into a chute for folding. It ejects the finished packages onto a conveyor belt. Finally, it sends the packages on their way to the customer. Lightweight, compact, and recyclable, Tetra Pak containers are eco-friendly. And that's certainly something to celebrate over a glass of fine wine. At a highway weigh station, inspectors weigh each transport truck on a road-level scale to calculate taxes on the goods it's hauling and to make sure the load doesn't exceed safety limits. You also find truck scales at grain silos, quarries, and other sites that move bulk products. The key to this enormous scale is a tiny component called a strain gauge, which sends signals to the scale's computer when compressed. They make the strain gauge from a laminate by bonding paper-thin sheets of nickel iron foil, epoxy, and Teflon in a press. Then they coat the laminate in a light-sensitive chemical and apply a plastic film with an image of strain gauges in negative format. Then they expose the setup to ultraviolet light. The light-sensitive chemical reacts, imprinting the images into the laminate's metal surface. Now they have rows of strain gauges. An inspector examines every gauge and marks any flaws to be discarded. Now, a technician measures how much voltage flows through each gauge. If it's too low, she raises it by rubbing off a microscopic amount of surface metal. When the strain gauges are finished, they cut them apart and send them to the load cell department. There, workers delicately tape 4 strain gauges into each stainless steel load cell. Then they solder electrical wiring to each one. The wires all run to a circuit board at one end of the load cell. And from the load cell, wiring runs to the scale's computer readout. The smallest amount of moisture or dirt would cause a strain gauge to malfunction, so they weld a cup over each one to hermetically seal it within the load cell. Every finished load cell undergoes a quality control check to verify that it works properly. The testing machine applies weight in increments until it hits the maximum weight the cell can bear, 34,000 kilograms or 75,000 pounds. The truck scale structure in which they'll install the load cells is called the weigh bridge. They begin assembling it upside down with a surface made of steel plates. To build the base of the weigh bridge, they lay out a grid of thick steel tubes and cross beams. Workers lower a guide to help them align the parts perfectly. Beneath each load cell is a pin. In order to weigh accurately, a load cell has to be level, so it's critical to make sure this pin is level before welding on the bulkhead that holds it. Once fully welded, the weigh bridge is assembled and ready for painting. The paint equipment laces the powdered paint with a positive electrical charge, and the weigh bridge with a negative one. This evenly draws the paint particles onto the steel like a magnet. In another department, they assemble the steel stand on which the load cell will sit. A welder tacks the pieces together, then a robot does the full welding. Now that all parts are ready, final assembly of the truck scale can begin. The weigh bridge, right side up now, contains 8 load cells at different locations. The first step is to install each load cell stand into its respective position. They insert a link on each side of the stand. They position the load cell at the top of the links and the bulkhead pin at the bottom. Then they close up the location with an access plate. The last step is to calibrate the scale. They lay a 10,000-pound weight on different parts of the scale to check if the digital readout is accurate. It takes a lot of time to get a truck scale just right, but it's definitely worth the wait. Pole vaulting began as a mode of transportation, not a sport. In Europe, men would use poles to propel themselves across bridgeless canals. In the late 1800s, pole vaulting caught on as a college sport. The athletes used bamboo poles to vault themselves over a horizontal bar. Today's poles are incredibly lightweight, yet strong enough to absorb the vaulter's energy, then throw it back to propel him over the bar. Some poles are made of carbon fiber, others out of this material, resin-impregnated fiberglass. The first step is to spread out the material and cut out the pole pattern. Meanwhile, a slitter machine cuts the same material into strips of a specific width. Then it winds each strip into its own roll. This spiral wrap machine automatically unravels the strip and wraps it around a hollow steel tube called a mandrel. This first layer of fiberglass gives the pole its flexibility. They wrap a second layer in the opposite direction, employing a crisscross pattern to increase durability. This second layer fortifies the pole's circumference. For the next layers, they remove the mandrel and lay it on a table. Now it's time for those fiberglass patterns they cut earlier. They heat the edge of the first one with an iron, melting the resin in the fiberglass until it's tacky. They stick this edge to the mandrel, then slide the other end between heated rollers. The rollers wrap the rest of the material around the mandrel, the heat activating the resin in the process. The same procedure now with the second pattern. This piece is critical because the way it's cut controls the way the pole bends. The mandrel and its multi-layer fiberglass coat now go into an oven. The heat generated by steam starts at 175 degrees Fahrenheit. This liquefies the resin so that it resaturates the fiberglass. Then the temperature gradually rises to nearly 300 degrees, solidifying the resin again, curing it. This entire process takes about 45 minutes from start to finish. And when it finishes, a pole extractor slides the mandrel out of what's now a fiberglass pole. The pole moves onto a flex machine. In part, this is a stress test. If there's any type of defect, the pole will crack or break. But the flexor also permanently puts a specific degree of curve in the pole, which helps the athlete vault higher. Now they make what's called the soft side mark. This helps the pole vaulter locate the bend in order to know where to grip the pole. Next, they apply a maximum weight label, indicating how heavy the vaulter can be. To finish the surface now, they mount the pole on a spindle, then run a polishing pad over it. Then, using a solvent, they clean off the debris. Now that the surface is pristine, they wrap it in thin, lightweight tape. Different colored tapes designate different pole styles. They cap the top of the pole with plastic. Then at the bottom, mallet on a molded tip made of hard rubber. The finishing touch is the manufacturer's decal. Vaulting poles come in various lengths between 10 and 16 feet. A pole designed for a heavier vaulter has to be stiffer than one designed for a lighter vaulter because the pole has to propel more weight with the same degree of bending. Top-of-the-line pizza cutters and vegetable peelers can be a pleasure to use. They make preparing and serving your favorite foods quicker and easier, and are ergonomically designed for style and comfort. They are also easy to clean and guaranteed for life. Vegetable peelers and pizza cutters work like a charm, making straight cuts without damaging your pans or your fingers. Quality pizza cutters start with cutlery-grade high-carbon stainless steel, from which a stamping press punches the cutter blades. The blades go through a three-step heat treating process. First, they enter a high-temperature furnace. Then it's into a deep freezer to maximize hardness and corrosion resistance. Finally, they go into a tempering oven, which increases the durability of the metal. A polishing machine with two buffing heads then polishes both sides of the blade, giving it a protective and cosmetic finish. A worker then loads the blade onto a bevel grinding machine that thins out the edge of the blade. It grinds a beveled edge that is thin enough to cut pizza, but not sharp enough to cut your finger or damage a cutting surface. A worker puts a steel bar insert into an injection molding machine that makes the soft polymer handle. He then cools it down in water. He puts the handles on an extraction fixture, which removes the inserts, making the handles ready for assembly, along with all the other molded parts. He then attaches what's called a swing arm to the blade holder, and he secures it in place with a screw. He dips the tip of the blade holder into lubricant and uses a pneumatic assembly fixture to insert the blade holder into the handle permanently. Using the swing arm, he snap fits the blade onto the blade holder and hides the swing arm screw with a cover cap. Finally, he ensures the blade rolls properly and safely, so it will cut through pizza with ease. The finest vegetable peelers also do their job quickly and effectively. They also start with cutlery-grade stainless steel blades that undergo tempering to ensure the metal is durable and corrosion resistant. After cleaning and polishing, the blades are dried in a vibrating medium of ground corn cob, then removed from the tub by a magnet. The blades are now ready for sharpening. A worker mounts the peeler blades on a computer-controlled edge grinding machine. The grinder sharpens one edge of each blade at a time. Once both sides of the peeler blades are fully sharpened, they're ready for assembly. Meanwhile, an injection molding machine makes the blade holders. A worker dips each blade holder into lubricant and inserts it into the molded soft polymer handle, joining them together permanently. Finally, he attaches the blade by deflecting the holder just enough to insert the tip of the blade into a tiny hole. These top-quality vegetable peelers are sold individually or in combination with other kitchen utensils like pizza cutters. And they sure are handy in the kitchen, even if you're not. We've been using wallpaper to add color to our homes for a long time. The use of wallpaper dates back to 15th century England. At first, it was seen as a cheap substitute for tapestry and panels. But over time, wallpaper gained wider appeal. Even today, wallpaper is a popular alternative to plain paint. When it comes to variety and design, wallpaper has really got it covered. To make the vinyl base for wallpaper, they pour water into a giant mixing bowl, add stabilizing powder, and a lot of plastic pellets. They add solvent, which helps to dissolve the plastic pellets into the mix. Big beaters stir it all up. It starts to look a lot like pancake batter. And just as if they were making pancake batter, they add ingredients incrementally. A little more powder to thicken the mix. And more plastic pellets for good measure. When the mix reaches the right consistency, they pour it between rollers onto one side of special paper. An applicator roller spreads the vinyl mix evenly onto the paper. A jumbo reel rolls it up and then unwinds it again. Here, nozzles fill trays with paste. Rollers pick it up and apply it to the back side of the paper. Electrically powered rollers pull the wallpaper through a gas oven, drying the paste. Then they wind up the paper again, creating a giant reel. A circular blade now slices through the center of the paper. This turns the one roll into two, each one of them 21.5 inches wide. They pull off a sample piece and tear the paper away from the vinyl. They're checking the adhesion and if the vinyl is durable and smooth. Meanwhile, away from the production line, stylists experiment with paint. They brush colors on a design that they've selected. They select 5 to 6 different color combinations because this design will be printed in many hues. Each color requires a separate print roller. The design is engraved into each roller. A worker applies some ink onto one of the print rollers. As the wallpaper turns on a big drum, vinyl side up, the print roller transfers the image onto the paper. Each cylinder layers it in a different color, building up the design. Darker colors are achieved by deeper engravings on the print cylinder because they transfer more ink to the wallpaper. Conversely, shallower engravings produce lighter tones. When they have the final proof, they compare it to the original artwork. If the colors look right, the design goes into production. There's no turning back now. The ink is ready, and the paper roll travels through a web of print cylinders. Here, print cylinders build a dolphin design onto the vinyl side of the paper. To dry the ink, the paper travels through a hot blower system. This is the view from below. Photos are taken and viewed on a monitor to get a close look at the quality of the wallpaper print. If it passes inspection, they roll the wallpaper onto a big reel. Some wallpaper has a flat finish, but they often emboss it, making raised designs. This creates texture. Blades from above and below cut the wallpaper into 32.8-foot rolls. A conveyor system transports the wallpaper to a machine that shrink wraps it. And then it's off to the showroom, where you can pick your favorite design. More than a century ago, welders first fused two metal surfaces by melting a metal stick over them using an electric current. That stick is now called a welding electrode. It's the simplest and most popular way to weld. Farmers and mechanics often use this tool to repair heavy machinery. This company's electrodes are coated with powdered metals and minerals. During welding, the metals melt and the minerals protect the area from oxygen, which would weaken the bond. The electrode transmits an electric current that heats and melts both the electrode and the metal surfaces, welding them together. Thin metal wire forms the electrode's core. The kind of wire depends on what the electrode's designed to weld, but most often the core is made of carbon or stainless steel. A machine simultaneously spins and bends it, evenly reshaping the wire until it's completely straight. 4 metal rollers then push and guide the wire into a guillotine. The blade chops the wire into segments that'll become the electrode cores. These segments range from 10 to 17.5 inches long. The factory puts a variety of metals and minerals in the coating. The metals are often nickel, manganese, and iron. The minerals, alumina, magnesia, and limestone. They also add a colorant to differentiate the models. Workers mix the ingredients with a bit of glue until they turn to the consistency of wet sand. A worker then packs the mix into a machine that forms it into slugs with a hole down the middle. He adds a plastic cap, then a metal cover slides on and the machine takes over. It takes only a minute for the machine's piston to compress the powder into a solid. Now to put the powder coating on the core wires. A worker loads 4 slugs into an extrusion press. It'll apply 120 tons of pressure on the slugs to shoot the powder through nozzles that'll coat the wires as they pass through the slug's hole. To load the wires into the press, they first stack them in this feeder. The opening at the bottom is adjustable for different diameters because core wires range from spaghetti thin to pencil thick. These rollers pass them through the press one at a time. Four wheels then pull the wires from the feeder into the extrusion press for coating at a rate of up to 1,000 electrodes a minute. When the coated electrodes emerge, they hit a metal wheel that positions them on a conveyor. A sander removes up to 2.5 inches of coating from the bottom, where you grip the electrode, and it bevels the tip so it conducts electricity even better. A worker now checks for uneven coating and to see if the wire's well centered. The coating dries at room temperature for up to 72 hours. To cure the coating, workers put the electrodes in an oven heated to 905 degrees Fahrenheit for up to 5 hours. Once they've cooled, the electrodes head into a printing press. An ink wheel first prints the model and type of current that's required. Another ink wheel then applies a color to the gripping end. It's another way to differentiate the model in case the lettering on the side rubs off in storage. From there, it's off to packaging. An optical scanner counts the electrodes, then a stacking machine separates them into 7.7 to 11-pound bundles. Finally, a worker inserts them into cardboard canisters. He adds a piece of cardboard to compress them tightly for the trip. A sticker marks the contents and tape keeps the package tightly sealed.